Hi everyone. In this video, I'm going to be talking about the octet rule and various limitations of the octet rule. Now, chemistry, as we all know, is all about reactions. Okay, reaction between atoms to form molecules, and also only certain atoms combine to form only certain molecules. Okay, scientists a long time back had a very beautiful habit of asking this question of why. Okay, so scientists had this question, why do atoms combine? Today we know that atoms combine to form molecules and we know a variety of them, okay? But they used to ask why. And they used to answer also by giving certain theories. So scientists had this question that why are atoms combining, and one such theory which tried to answer this question was a theory by Kossel and Lewis, okay? This theory tried to explain the most important question, that why do atoms combine? And this theory was based upon the inertness or nobleness of noble gases. Now what are these noble gases? The group 18 elements are called noble gases, and we all know that, okay? And they're called noble gases because, well, they're noble, which means they do not react or they do not form any compounds. They do not react with other elements, or they do not form any compounds with any other elements, right? Whereas instead of them, all the other elements in periodic table react, okay, with some or the other element, but they definitely react. So why are they reacting and why are noble gases not reacting? What do noble gases have which all the other elements do not have? And that is what this theory is based on. This theory basically says that 8 electrons in the valence shell is something that every element is craving. And this is something which noble gases already have. And because noble gases already have this, they do not need to react. Whereas all the other elements, because they do not have it, they are craving for it, and because they want to get 8 electrons in their outermost shell, they do the reactions which they do, okay? So to complete this 8 electrons in their outermost shell, the elements can either do transfer of electrons, a complete give and take of electrons, okay, which happens in case of your ionic bonds, or they can take part in sharing of electrons, which happens in cases of covalent bonds, as we know. Basically, bottom line, all the elements want 8 electrons in their outermost shell, and because they want to do that, they're going to perform the chemical bonds which we see around us, okay? Now, how many electrons they are having in their outermost shell? So, as we see, the first group is having 1 electron in the outermost shell, the second is having 2 electrons in the outermost shell, 13th group is having 3 electrons, then 4, then 5, then 6, then 7, then 8. Okay, so noble gases are having 8 electrons in their outermost shell, so basically they are done with life, but all the other elements are not having 8 electrons in their outermost shell. So depending upon their comfort, which means depending upon the comfort of either transferring, which is giving and taking of electrons, or sharing, they will achieve this 8 or octet in their outermost shell, and once they achieve octet, they become inert and hence they become stable. Okay. It is now important to understand that all the noble gases have 8 electrons in their valence shell, which means they have a complete octet, which apparently provides them certain stability. Whereas helium is having not 8 but 2 electrons in its outermost shell, and this configuration is called a duplet, which apparently also is a stable configuration, and this provides helium atom a very stable configuration, and that is why hydrogen atom, which is having just 1 electron, tries to complete its duplet, because of course completing 8 electrons is going to be quite difficult for a hydrogen atom, so it tries to become or tries to achieve a duplet, just like your helium gas. Okay, now talking about a classic example of ionic compound, which is basically sodium chloride. Okay, now, this sodium chloride is a classic example for octet rule, where both sodium and chlorine are trying to achieve a noble gas or 8 electron configuration by giving and taking electrons. We have sodium whose electronic configuration is 1s2, 2s2, 2p6 and 3s1, and chlorine whose electronic configuration is 1s2, 2s2, 2p6, 3s1 and 3s2 and 3p5. Okay, now the rule says that we need 8 electrons in the valence shell. So if somehow sodium is able to give out this electron, we get a total of 8 electron in its valence shell, which is the 2 subshell, and it's going to be a good day for sodium atom, right? Whereas in case of chlorine, if it's somehow able to gain 1 electron, it is going to be 8 electrons in the 3 subshell, and that again is a good day for chlorine. So this happens, it's a match made in heaven. Sodium gives out one electron which is taken up by the chlorine atom and becomes sodium chloride, and hence it is an ionic compound which is formed by give and take of electrons. On the other hand, in case of chlorine molecule, both of them are having 7 electrons in their outermost shell. By sharing one electron each, they both achieve 8 electrons in their outermost shell, and that gives this molecule extra stability because now both of them are having 8 electrons, which is the octet, which is the inert gas configuration. So this is a classic example of a covalent bond in which the octet rule is. So the octet rule was a very celebrated theory of its time because it was actually able to explain bonding in many different compounds, including water, ammonia, methane, okay, and many different compounds, and the list is too long, okay. But as time passes, researchers go on, and it was later discovered that octet rule also has limitations, okay. It is not a very successful theory because it does have certain limitation, and basically every theory has some or the other limitation of its own. The main one being that it is based on the inertness of noble gases. Okay. The base of this theory is that noble gases are inert, they will never react because they are noble gases. But xenon, which is a noble gas, does form compounds with fluoride. Okay, it does form compounds with fluorine, it does form compounds with oxygen and fluorine. So basically the base of this theory itself is not correct. Okay. More than that, we have some compounds which are formed which do not have 8 electrons in their outermost shell, and still they are formed, right? First one, we have configurations in which there are electrons less than 8 in the outermost shell of the central atom. Examples is BeH2. Here beryllium has only 4 electrons in its outermost shell. Example AlCl3. Here Al has a total of 6 electrons in its outermost shell. Such configurations where the outermost shell does not have 8 electrons but only less electrons than that are called hypovalent configurations. Okay. Also, we have compounds in which the central atom has electrons more than 8. For example, SF6. In SF6, we have a total of 12 electrons in the outermost shell of sulfur, and which is of course much higher than 8. And such configurations in which the electrons are more than 8 with the central atom are called hypervalent configurations. Okay, so we do have compounds which do not have 8 electrons in the outermost shell and they are still formed, which basically tells us that 8 rule or 8 electrons in the outermost shell is not a necessity and is something which, if it happens, great, but if it does not happen, it does not define whether a molecule is going to be formed or not. Okay, so this was the main limitations. These were actually the main limitations of the octet rule. So if you have any doubts in this video, you can comment that down below. I will definitely try to answer. For more videos like this, keep watching. Stay tuned for more.